Hello and welcome back everyone. I thought it might be nice to put together a highlight summary from some of my popular videos. G'day, I'm Steve-O and welcome to the Outback Shed. This short clip shows a hammer I bought in a street market in Shanghai in the late 1990s. I paid about $2 for it, and when I returned home and dug it out of my suitcase, I couldn't figure out why I only bought one of them. It is a very useful tool to have in my toolkit and it gets a bit of use. This is the tollgate matrix I use for planning my projects. I was a senior project manager in a previous life, and old habits are hard to lose. Anyway, I enjoyed planning and tracking, and this method provides some structure and order to my projects. These are the thumbnails of videos I've posted to date. I've selected several for your interest. First off, the 4-jaw chuck centering tool. This project was inspired by a tool I made at night school in the early 1980s. I find that stainless steel doesn't produce a very nice and friendly swarf when taking a very small cut. It tends to be fine and stringy and prone to bird's nesting. The original tool was made from mild steel. I'm making this one from 304 stainless. Target size is 18.86 and we've got 18.83. My knurling tables got their first view in this video, and they provide the starting diameter required for the best opportunity to achieve a successful knurl. There are many different views on knurling, but if I start with the correct diameter for the knurl I want, I will substantially increase my chances of producing a successful outcome. That's not to say I don't get double tracking from time to time, but it is rare. I can say now that I've got a good imprint with no double tracking. There are varying views on whether to take a heavy or light cut on the first pass. What I find works for me is to take a decent bite without being too greedy. I'm going to run the knurl down the whole length of the bar and then cut out those bits that I don't want. This is preferable to making individual knurls along the bar. Stainless steel is not the easiest material to knurl. Brass and aluminium are far more forgiving and far less stressful on both the machine and tooling. That's a good start to the knurl and I'm happy with that. It's a good imprint across the whole length of the workpiece. Now I'm going to go back on the tool and apply a little bit more pressure, restarting the knurl, then reverse feed and go back the other way. After 5 passes, the knurl is now fully formed. It's produced a nice knurl and I'm very happy with it. Now that the centre has been turned out, I can work on the taper. One final pass and the tool is complete. This is an accurate tool and I'm very happy with it. I've used the original tool over many years and now I've got a new one in stainless steel. This is a good first lathe project for new users as it employs many features of the metal lathe: knurling, plunge cutting, 3-point steady and taper turning, to name a few. And for the seasoned machinist, it's a great rainy afternoon project to make a very useful tool. The quick change tool holder storage tree idea came many years ago when my friend and mentor, who was my old high school teacher, made one for his Colchester Triumph 2000. That would have been sometime in the early 1980s. The trees are made to hold 12 tool holders, either empty or with tooling mounted. This ensures that the required tooling is always at hand and it doesn't take up too much room on the bench or get knocked around in a drawer. The internal scarf has not been removed in these tubes and you can hear the tool clicking as it cuts into it. This is a result of the tube making process. The tube starts its life as flat stock. It then goes down a process line with roll stands that form the tube into a circle. This is then fusion welded in a continuous process to form a tube. The external scarf, which is a remnant of the weld, is removed with a carbide or ceramic scraper. Some tubing is manufactured with the internal scarf also removed, but not on the pieces that I have. The high-pitched soundtracks on the speed-up sections of the video are caused by the change in frequency in iMovie when the footage is sped up. This was the software I was using at the time. I now use Final Cut Pro and that program preserves the soundtrack at the original levels. That's a good fit and I'm happy with it. Now I'll turn it around and finish off the other side. That's working well. I'm not locking the divider spindle to allow the tap to find its own path. I find that in these situations the tapped hole does not tend to come out oversized. I'll repeat the process for the other cap off camera. I have a spare hand wheel that I will use as a base for the larger tree. It has a 20mm bore, but the shaft I will be using is 19mm. This means that I will need to make a sleeve at the hand wheel to take up the gap. The easy way of doing this is to machine a 20mm interference fit plug, press it into place and machine it back to size. For the larger tree I used a spare saddle handle, and for the Colchester I used a large piece of aluminium for the handles. I've set the hand wheel up on the press and it's a simple matter of just pushing it into place. I will need to bore a 19mm hole to match the shaft, but as the sleeve will be left with a 0.5mm wall thickness, I'll need to go carefully to bring it to size. I have the bar set up in the mill to cut the 4 slots to take a hook spanner. In hindsight, a better approach would have been to machine these slots before drilling and tapping, as I could have supported the bar with a tailstock. I'll now support the bar in a V-block and clamp it to the table. Not the best solution, but an improvise. I'll need to take small cuts. The shafts need to be turned down to a little under 16.5mm to allow the 18mm nut to pass over it and reach the threads, which will be just above the bottom plate. I've machined a gutter for the threading tool to run into and made a scratch pass. I'll take the thread easy and not push it too hard. Once I get close to size, I'll run a die over the thread to clean it up and get it to its final size. That's a little firm, but it's what I expected. After removing the die, I'll run a file over it. I used the belt sander to round the ends and provide a fit around the tubes for welding. However, the camera had a hissy fit and threw its toys out of the cot, so I don't have any footage of that. All that remains now is a clean up of the power file, and this part is done. Welding is something I don't do a lot of, and along with other similar hot works, it's something I don't do in the shed. These works are only done outside. I don't profess to be a welder, but I can stick metal together a bit better than double-sided tape. Well, just a bit. After placing one tack, I use a spanner to change the alignment as needed before running a full weld across the bottom of the branch. As I have several projects in the plan that involve welding, I'll binge watch some cutting edge videos and then go outside and get in some practice. I'm using a high-speed steel tool for this material as I seem to get a better result than I do with carbide. I really don't like the swarf produced from this material. It's a lot more dangerous than it looks. The carbide parting tool works alright as the rake profile tends to pull the swarf away from the cut edges. Frequent clearing is often needed. After a trial assembly, I'll send the trees out for powder coating. I would have preferred to match the lathe colours, but this wasn't possible, so I settled for a completely different colour, flame red. I've used this colour before on previous projects, so they won't be out of place. Most of the build came from materials I already had. The bearings were $40 and the powder coating set me back $100. I just need to rearrange the bench top to find a home for it. This storage system can be used for any type of quick change tool post and any size of holder. The same design works well whether you prefer to store your holders empty or with tooling fitted, or a combination of the both. This simple chuck attachment will allow the machinist to remove the workpiece from the chuck and mount it on a mill table with complete confidence of accuracy. The fixture consists of a height block and a T-nut for each slot. The height of the block is just higher than the face of the jaw's first step. Some of the video I will be showing here dates to before I started my channel. That footage was shot on different cameras with different lighting. It was filmed during the period when I was experimenting with cameras and lighting. That footage, unfortunately, is not up to the normal channel standards. Here I'm milling the height block from a piece of mild steel bar. I'm just using a high-speed steel end mill. I don't have coolant set up on the mill currently. Although making chips is fun, the swarf is certainly not user-friendly. The initial measurements show that the blocks are within a few thou of each other, but they will still need skimming prior to use. They will also need reskimming every time they are fitted. The chuck jaws must be removed from the chuck prior to skimming those parts of the blocks that will support the workpiece. I'm using a 32mm boring bar to do the facing. I still have the ER40 collet chuck mounted from a previous build, and that looks like an opportunity to take it for a spin. I have some 20mm 2011 aluminium bar stock mounted to make 4 risers that are 20mm long. I'll just clean up the outside diameter, then bore an 8mm counterbored hole to take a cap screw. I've seen others make risers out of cap screws held secure with a lock nut or a clamp block, then dial them in with an indicator. Those are good systems, however I prefer this method as I can simply machine the risers to the size I want without making any adjustments. I'll put a light coat of die chem on each face, then remove the chuck jaws before machining them even. The sound of the cutter is a giveaway for the risers not being even in height. The elevated sound level of a slow-mo confirms this. Even cutting clicks on the final cut show that they are all the same. This is then confirmed by the dial indicator. After loading the plate into the chuck with some support from the tailstock, it's easy to see how this setup works. The bandsaw has a capacity to cut 225mm rounds, so this piece is well within its capacity. I picked up a BS2 divider off the specials table at a local supplier. What I thought was a good deal didn't quite turn out to be, as several components were missing. However, it has made a good divider at a little less than half the cost of a new one. This is the divider edge, so after a reference cut to set the DRO, I'll bring it close to size and use a 6mm form tool to finish the back. This is a nice tool and it does do a good job, but it produces a very stringy swarf. Chamfers all around and I'll cut the thread. I put a coat of die chem in the bore so that I can zero the DRO. I can also see the progression of the thread. This is a metric lathe with a metric lead screw, so I need to reverse the tool and not use the thread dial indicator, as this is an imperial thread with 8 teeth per inch. This swarf tends to bird's nest, a good reason to keep the chuck guard in place. I know most people take them off, but I prefer to keep mine in place. I'll set the backplate up on the mill table and centre the spindle using the DRO with an electronic centre finder. I'll bring the spindle to the centre and set the DRO to circle mode. The first request is to confirm the spindle is centred. The next is to confirm the PCD. For this project it is 104.5mm. Next is the number of holes, and that's going to be 4. Then the starting angle from the x-axis, enter 0 to confirm, and the end angle, again enter 0 to confirm. Good to go. The DRO now shows the location of each of the 4 holes and the coordinates for the x and y axes. Hole 1 is selected, and I'll bring the table across to 0 out the coordinates and draw the hole. I'll centre drill each hole, then drill, chamfer and tap each one in turn. The spindle adapter mounted in the 4-jaw means that I can mount the faceplate, the 3-jaw chuck or the 4-jaw into the lathe and turn apart. Then transfer the chuck with the part intact to mount it directly into the divider. This will guarantee accuracy of any features I machine into the part on the mill. This is particularly useful for gears and other parts requiring precision. For all this divider was not the bargain I had hoped for, it's now complete and is a very versatile piece of tooling. Drawing. I'm not into CAD and I don't have specific drawing software, so for this project I'll fabricate a not to scale concept drawing in Excel. I will make 3 hammers. Each will be different but based on the same plan. One will have an aluminium head with an aluminium handle, one with an aluminium head and a stainless steel handle, and one with a stainless steel head and an aluminium handle. There will be a mixture of inserts made from copper, brass and wear-long. This will provide 3 hammers with totally different characteristics and balance. The dowel ring I have is 60mm in diameter and I don't want to cut that down to 30, so I'll make those at a later date when I have some stock closer to the size. The plant is flexible and a guide only. I'll make some fine adjustments during the build. A machinist hammer is something I've wanted to make for a long time. Initially, I couldn't decide what to use as the best materials, so I chose to make 3 hammers, each with a different combination of materials and hence different weights and balances. Stainless steel, aluminium, brass and copper were logical choices. Again, knurling gets a solid mention in this video. Both aluminium and stainless steel get the treatment. This aluminium is 2011 grade, but it's not producing a nice swarf, just a shower of small bits. So I'll put a cloth on the lathe to try and contain them and keep them away from the bed wipers. From the tables, my target is 22.33mm. Putting plenty of oil on the knurl, there's a fair amount of debris in the oil that's draining, but that's normal for softer metals. That's produced a nice knurl, and I'm very happy with it. Each head requires a 25mm deep threaded hole in each end to attach the inserts. I think it was around this point that I upgraded my microphone to studio quality. I also started to record the commentaries in GarageBand rather than directly into the video software. This provided me with the opportunity to clean up the soundtracks and make them more professional. It's fair to say that post-production editing and video production have become a hobby in its own right. Although I have a tailstock tap holder, I tend to use a drill chuck to hold taps for threading blind holes. If the tap bottoms out, it will spin in the chuck, whereas if a tap chuck is used, the tap will break. Brass tends to throw a shower of fine particle swarf everywhere, and it sticks to everything. So I use a small thin paintbrush to capture the swarf and drop it directly into a tray, making it easier for recycling. After threading and turning to rough size, I'll part it off. I've never machined copper before, and this piece is crumbling and the insert just doesn't like it. But I squirted some WD-40 on and it seems to have made a huge improvement. Nice cut and nice swarf, although the lathe does seem to be labouring a little. The slow-mo shows that the swarf is being produced slower than the rotation rate of the workpiece. That might suggest some compression of the swarf is occurring. It's also pushing a bead in front of the insert. Although I'm not sure what that means, it is cutting fine, so I'll take it. Machining the copper inserts is shown to be the most often played part of this video, by a long shot. Another run with the die holder and the part is threaded. I'm parting off under power feed and it's working well. Not sure I would want to do that manually. I've set up a bar and a boring bar holder and the differences in balance can be seen. These three hammers provide a combination of different weight and balance characteristics, with each having its own unique personality. I guess over time I'll decide which one I like best. This next video has been very popular. There are two separate builds. An ER40 and a 5C collet chucks were mounted to backing plates converted from spare faceplates. I only showed the build from the first backplate as there was little to be gained by repeating the footage. The measurements and results obtained were the main story. I'll use a spare faceplate and convert it to a backplate for the collet chuck. I'll need to reduce the diameter to a manageable size, and as the speed rating for the faceplate is low, reducing the diameter will allow the chuck to be used at higher speeds. Using a 16mm solid carbide end mill, I'll slice in between the slots. This is nice cast iron and it's cutting very well. You didn't really think I was going to trepan it in the lathe, did you? Well, it's the same thing. I'm just using a mill, which as we all know, is just a lathe standing on its end. I'm leaving some small tabs at the bottom of some of the cuts to provide structural integrity to the plate. I don't want it to move or break free on the last cut. Cast iron tends to cut well if a robust cut is taken. Finer finishing cuts tend to produce a powdery swarf, but all cuts produce some fines which linger in the atmosphere. So a dust mask is appropriate, and I use a vacuum where possible. I'll now separate the two pieces with a hammer and chisel. Mounted onto the lathe, I'm using a 10mm high-speed steel tool bit to clean up the milled edge and bring it to round. Carbide inserts just don't like interrupted cutting. I have the lathe well covered, and I'm using a vacuum to capture the fines and as much swarf as possible. The pitch circle diameter of 235mm I got from the previous plunge, and that's reapplied here. The DRO shows a graphic location of each plunge and the XY coordinates for each. It's just a matter now of setting the depth and plunging each in turn, moving the strap clamps as needed. I have an inverter fitted to the knee on this mill, so I could use a power feed, but I'd prefer to maintain a manual feed for these cuts. A mallet and a wooden block are often needed to dislodge the chuck for removal, as they can stick to the spindle nose, making removal difficult. The final chamfer on the front edge, and I'll face off the plate. I'm making the relief 0.5 mm oversized as I need some wriggle room to centre the chuck when I mount it. Next, I need to drill and tap 6 8mm holes in the backplate for the mounting holes. I'll drill these at a pitch circle diameter of 95mm. To get the best accuracy from this chuck, I'm making it a Set-tru so I can dial it in like a 4-jaw chuck before tightening the cap screws. I've clamped the backplate to an angle plate so I can drill 4 5mm holes right through to the centre and then thread the outside to take a 6mm grub screw. Now it's over to the Colchester to machine 4 5mm push rods for the chuck adjustment. These are a little under 5mm to allow clearance through the hole, and they're 35mm long. I'm showing one rod here, I made the other 3 off camera. The 6mm grub screws fit nicely, and you can now see where the push rods fit and how the setup will work. I use compressed air to clean the parts, but they still need a wipe of the tissue. I still have a few spare faceplates, so I'm happy to convert this one to another backplate mount like I did for the ER chuck. I machined the backplate off camera as I've already made a video for that build. I'll put a link to it at the end of this video if you would like to see it. I now have 2 350mm rings that I'll need to find another use for, maybe later. There are a few practical tests to do, so let's see how the chucks compare. I'll set the ER chuck up on the spindle, and I'll undertake all of the observations for this chuck, then change to the 5C chuck and repeat the observations as around during editing to show each for the ER followed by the same for the 5C chucks, as it makes more sense to see the same observation on both chucks before moving to the next. I'm using a MeasureMax test style indicator to measure the spindle run out to 100ths of a millimetre. Then I'll switch to a no brand test style indicator to go the next step and measure microns. There's very little movement shown on the hundredths indicator, while the high res indicator is showing maybe half a micron. I redialed in this chuck off camera. It was very time consuming and fiddly, but that doesn't make for interesting viewing. However, after a lot of patience, I got the best result I could. I changed the mounting cap screws for the ER chuck from stainless to hardened steel after reading the comments from a viewer left on the previous video. The indicators show the same run out as for the ER chuck, about half a micron. Moving it to another part of the taper shows the same result. The most versatile fly cutter was also a popular video. There have been many fly cutters made and uploaded to YouTube. Mine's a little different. I chose to make counterweights and cutter blocks of equal weight and engrave the plate on both sides so I could create the best possible balance for cutting. A 29mm drill followed by a boring bar will bring the hole to size. I originally planned to use a 32mm arbor for this project, but after seeing the machine plate I decided to go with a 40mm arbor. I want this fly cutter to have the ability to run in both directions and for the cutter blocks to be reversed. This will have two benefits. First, it will cater for any unforeseen configurations where I might need to approach the cut from the opposite side of the workpiece. And by reversing the cutter blocks in direction of rotation, I can significantly reduce the diameter of the cut. There is a downside to that though. The visibility of the insert in the cut will be compromised, and that might pose risk. I would need to think pretty hard before using it in that fashion. The slots are 25mm wide and 5mm deep. This allows for multiple possibilities of shop-made cutter blocks or converted commercially available tooling. I've machined 2 slots in each groove to take mounting bolts. I'm going to use 10mm cap screws to secure the blocks. Next, I need to mill slots to take the arbor drive dogs. As the plate is reversible, I'll machine these on both sides of the plate. As this is a large fly cutter, the weight of the cutter block will need to be balanced by a counterweight. To assist in setup, I'm engraving each end and each side of the plate. I can use the DRO to ensure that the start point is the same for each set and to ensure that the tick marks are accurate and consistent. The 1mm tick marks are 5mm long, the 5s are 7 and the 10s are 10mm long. I'm using a high-speed steel cutter to do the engraving rather than a diamond point or a drag engraver, as I want a rough surface inside the cut. I also don't have a diamond tool. A laser would be great if I had one, but I don't. I've mounted in the lathe and I'll clean off the excess with some 1200 sandpaper held with a stick. That looks fine and I'm happy with it. Next, to cut the clearance for the insert. I've set the vise to 0 degrees again and set the block up on a 45-degree angle. The pocket looks off angle, but that's just perspective. The pocket is at a 15-degree incline and the camera is not square to the vise. Back to the scales and the final machining weights can be seen. These scales are accurate to 1 gram, which means one piece could be nearly half a gram over or nearly half a gram under. So what appears to be equal on the scales may not be so precise. However, for this project, they will be fine. I made 3 sets of cutter counterweight combinations with other options to be built in the future. Using the mill, I'll engrave the clamp caps. Now to assemble the parts. The finish is very good. Both SEK cuts produce a very smooth surface, and I'm sure with some tweaking of speeds and feeds I could improve on it. The TPMR produced a nice finish, but is slightly grooved and not quite as smooth to the touch, but it's a good finish all the same. Again, fine tuning would likely improve the outcome. The other one, I'm using 50 by 50 steel angle, 5mm thick. I'll cut it to 900mm long. I'll use the bandsaw to chamfer both face ends to 45 degrees. I have a piece of aluminium bar stock 90mm in diameter, and it will do nicely as a former for the circular end. The circumference of the former is a little over 280mm, but the tight corners will need a little more, so I'll allow for this by making a 300mm allowance in the bar for the curve. Finding the centre of the angle, I'll mark 150mm each side and then make lines at 45 degrees. These will be the cut lines. I'm going to use the bandsaw and the mill for this project, but this tool can be made with a hacksaw or an angle grinder. Machine tools are not necessary, meaning that this build is not restricted to only those who have machines. I'll adjust the vise swivel base to 45 degrees, then cut one of the angles for the top. Then I'll swivel the base the opposite way to cut the angle for the other end. The graduations on the vise base are close enough for this build. Angle block accuracy is not required. Next, to retram the vise back to 0 to make the first of 2 cuts to separate the offcut from the bar. The 5/16 end mill works well, but the bar does show a little vibration. Ideally, an Ausee torch would be the go, as it would provide much more heat a lot faster, and it would be localized. As this is the only torch I have, it will just have to do. Now I can hold it in the vise and heat up the tight bend locations, then use the vise to pull the curve around the former. Clamped up, I'll leave it on the bench to cool. This is a right angle bend in 2mm sheet. They're going to be hammer marks, but I can reduce these by using the leaves as a compression vise. This tool is not just for bending steel, it can be used as a shear as well. I'll use some aviation shears to nick both sides of this 2mm offcut on the line I want to cut. This will deform the edge so that it will seat on the face of the tool leaf. Then, using a cold chisel and hammer, I can shear off the waste piece. The bench is moving around a little as it's mounted on wheels and not bolted to the floor. The cut end will need a clean up with an angle grinder or file. I'll use a power file. This tool will greatly increase the versatility of any vise. The spring in the jaws naturally causes the bar to be held and retained in the vise during tightening and untightening operations. The Diamonds and Balls project was inspired by several other YouTube builds. Credit where credit is due. Making a burnisher out of a grinder dressing tool was always a long shot. In this case, it proved unsuccessful, but it was a worthwhile project. I'll revisit this tool at some time in the future if I get any ideas to improve it. I have ideas for a later project to build a burnishing tool that will burnish up to tight corners in both left and right hand directions, but that's a project for a later date. I was given this mini lathe by a friend. After cleaning up, I installed a 200 watt motor, a speed controller and a digital tachometer. The project started as a single video, but when I went back and made further improvements, including new chucks and better options including new tool posts, I made a second one. There was a lot involved in this restoration: electrical, pulleys, arbors for new chucks and tool posts. There's a future opportunity to refine the pulley setup and make improved drive belts. After a few strokes with an oil stone, the edges look fine. The large pulley set follows the same process. I'm using a new T and GG insert which I got from Livetools. Big shout out to Alpha. It's producing a nice finish. I'm cutting the V by side shifting the cutter to reduce the cutting load on the tool bit. This helps in bringing it to size. It's now a simple matter of parting off and then back to the mill to bore and tap another hole for a grub screw. I'll need to make a new nut for the driven pulley with a hole drilled partially through the end to retain the magnet, which I'll hold in place with a few drops of resin. Test one. I bought two new chucks, a 50mm 3-jaw and a 65mm 4-jaw, but they both have M14 threads, so to use them I will need to make conversion arbors to fit the Unimat spindle. I'll put links to these chucks in the description. I'll make them from mild steel. I'll bore and tap a 12mm by 1 internal thread to fit the spindle. Then with a drill and a boring bar I'll take out the end to finish to a register to fit the spindle nose. Simply part them off and then onto the mill to machine 2 spanner flats for a 19mm open-ended spanner. There's only 1mm between the root of the 14mm thread and the crest of the 12mm thread, and that does not leave a lot of metal, so I will need to be careful not to cut the gutter too deep that weakens the part. A quick chamfer all round and it's done. The posts are mounted to the cross slide with a 6mm socket head cap screw, the same as the original. But I'll put 3 screws to mount the tool bit rather than 2 in the original tool post, as this will provide more flexibility when using small bits. Ouch! That's what happens when you don't stop the mill quick enough when starting the tap in order to finish the thread by hand. Now it's set up, I can run each of the speed ranges to see what speeds I have. Looks like some belt slippage is occurring, but with a round belt and a V pulley, I guess that's going to happen. I'll make some assessments on what speeds I want and then make a new pulley set that is profiled to fit the belt. The current pulley set has 3 steps. I think a 5-step set will be a better solution. Well, it's been an interesting year. I haven't completed as many projects as I would have liked, but some surgery and a slow recovery had a part to play in that. I hope you enjoyed these project highlights. If you would like a copy of my knurling tools, you can take screenshots or you can send me an email. All I ask is that you subscribe to my channel if you haven't already. There are plenty of projects in the plan that are yet to be made, and if you have an idea for one you would like to see me make, please leave a note in the comments. As always, thanks for watching. If you like this video, please consider subscribing to my channel and give it the thumbs up. Also leave a comment if you like. I do read all the comments and reply where I can. Be productive, be creative, but most importantly, be safe in your shed. Catch you next time.